Okay, good morning to all of you. Today I have come here again for a revision class. I will just try to cover 2-3 topics. Maybe there was a request from the student side to briefly revise about hypothalamus, thalamus, and some tracts. I will just go through the basic slides and I will explain to you the basic concept. The details of the fine details of the subject you can have it from your book. I will just give you a basic understanding of these three topics here. But before that, I would just like to make an announcement here. Hope everybody has joined it, and those who have not joined, I would request that you all who are here convey the message to them. Now, there was a thinking going on very strongly that the colleges may start from 1st September. You may be asked to come back from 1st September. If at all that happens, you may need to come to college. But more than that, I was referring to the earlier circular of the MCI, which says that you will have 2 months time to complete the portion, whatever is left uncovered, either in theory and practicals. So they will give us 2 months time to complete whatever is left over syllabus and the other formalities which needs to be done. So after 2 months, the third month, first week onwards, you will have your regular university exams. These are the strict guidelines given by the MCI to all the universities and all to the colleges. I hope you would have seen this also. It has come about 10 days or 2 weeks earlier. I had also mentioned this about 10 days back. Now, assuming that the colleges start from 1st September or let's say 15th September or 1 October. Let us assume something. So the whole plan goes something like this. Whenever they start, let's assume 1st September. By 30th October, we are supposed to complete whatever theory topics are uncovered and the practicals. More importantly, in that is you also have to complete the pre-final exam in that, the theory pre-final and the theory practical pre-final and the theory pre-final, plus we have to tabulate the marks and calculate whether the students meet the eligibility criteria or not. Along with it, the attendance criteria has to be taken. So now whenever your colleges start, you will have to come to the college to complete those practicals which have not been completed, like for example the CVS examination, the respiratory system examination, the blood pressure, spirometry. These are some topics which have been left over and you need to come to the college. Plus we need to also take the pre-final exam into consideration, which will be paper 1 and paper 2 set by the university guidelines. So in the next, you have got a very narrow window where there is only 2 months time left for you to prepare for your final university exam, which will start from the third month onwards, and also to prepare for the pre-final exam theory and practicals. Now, as far as the things are going on, if we recollect back the first internal exam marks, you already are aware we had conducted one internal exam, first internal, and we were about to conduct the second internal exam somewhere in the March as per the university guidelines, and before that the lockdown happened. So we are also planning now in the third week of September, second or third week of September, to conduct an online internal exam. Now this portion for this exam will be something which was there for the second internal exam. So whatever was there in the second internal exam where you were supposed to write on March 15th or so, the same portion will be taken up. It will be an online exam. It will be same 2.5 hours duration. I will release the paper on the WhatsApp group which you have created. The question paper will be there. You have to write it on your paper, and after writing it, scan it through your cell phone or through your laptop or through your desktop, and the scanned answer sheets you send it through your email ID to my email ID, the details which I will give you, so that we will correct these papers, and as per the protocol and as per the university guidelines, the best of the first and the second has to be taken into account. So at least if you could do well in this online exam, we will take that marks into consideration and add it to the pre-final exam which we will conduct later on as per the university guidelines, and then tabulate your final internal marks so that you fulfill the eligibility criteria. So my request is that start preparing for your final exam, start preparing for your pre-final, thinking that both will happen very shortly. But immediate hand is the portion will be the same portion which was prescribed, which was given to you for the second internal exam, the same thing you will have. This will be an online exam which we will conduct it in the 3rd or the 2nd week of September. Maybe by next week, next Wednesday, we will release the dates and the portion finally. Okay. Now, coming back to our topics. One of the requests where I had received is to discuss about the revision topic was divided into the motor cortex. Now I will briefly run through these areas through the slides so that I will make it very simple and easy. You just need to go back after the class is over and add on to the subject by revising it in the textbooks. So the motor cortex. The motor cortex is divided into three sub areas where we have got a primary motor cortex and a premotor cortex and a supplemental motor area. So what is the primary motor cortex? The primary motor cortex basically is having a topographical representation, where topographic representation means the whole body, especially the head, neck, the thorax and the limbs are represented in the primary motor cortex. The main function of the primary motor cortex, it is that it controls the fine movements. The fine movements means the movements of the fingers and the toes are controlled by the primary motor cortex. So for example, when you are typing on the system or pressing upon the numbers on the cell phone, or a musician using his fingers on the violin, so all those fine movements are under the control of primary motor cortex. That is the main function of the primary motor cortex, and the representation, the area which the primary motor cortex represents is a topographically of the whole body. Something like a whole photographic picture of the body is embedded in this part of the motor cortex. The next area is the premotor area. What is premotor area? The area in front of the motor cortex is the premotor area. It is pre means in front of the motor cortex, and motor area means that it is controlling the motor movements. So the function of this motor cortex is it performs or it gives instructions to a group of muscles. Say for example, you want to lift something or you want to move your hand. The instruction to move the left upper limb from one place to another angle or to lift a heavy object, that instruction for that particular group of muscles, specifically to flex the muscles, comes from the premotor cortex. So it basically gives an instruction to a group of muscles to perform a particular task. Say for example, you are lifting a bucket of water. So to lift that bucket of water, the movement of the muscles required are that you have to hold the handle and lift it. So there is a contraction of the flexor group of muscles of the arm and the forearm. So this instruction for the muscles to contract comes from the premotor cortex, and this premotor cortex works in synchrony with the other other areas of the brain which are associated with the movement motor cortex. Let's say for example, the primary motor cortex or with the cerebellar area with the basal ganglion, it controls or fine tunes. So basically the rough instruction that there has to be a contraction of the skeletal muscles of the flexors of the arm and the upper arm when you are lifting a bucket of water comes from the premotor area. But how much amount of energy to be applied, how much force to be applied, and what angle it has to be lifted, all that fine tuning will come from the basal ganglion and the cerebellum. The topographic representation of the body in the premotor area is also similar to that of the primary motor cortex. Now, what is the function of the supplemental motor area? The supplemental motor area is more topographically organized. It basically results in coordination of the movements on both sides, that is bilateral movements. Whenever you stimulate the supplemental motor area, it sees to it that there is a coordination of the movement of the both sides. Say for example, when you are jumping involves movement of both the limbs, or when you are falling down, when you fall down with the outstretched hand. So this movement of the hands, muscles contracting to stretch the hands, is a bilateral event, and that is coordinated by the supplemental motor area. Similarly, as it says that it works in association with the premotor cortex, and basically the function of this is to fix the movement of the body or to take an attitude or give a position to the body in any movement happening. So if you see the word supplemental, supplement means it supplements. What it supplements? It supplements the function of the premotor and the motor cortex. So whatever is the function of the premotor and the motor cortex in the premotor area, that is supplemented by the supplemental motor area. The topographic organization is similar to that of the premotor cortex and motor cortex, but it is more organized and it controls the bilateral movements and gives position and attitude to the body. So this is the things here. If you see, this is the primary motor cortex, the front part will be the premotor cortex here, and the other areas is the supplemental motor cortex. So here if you see the topographic organization, the upper part of this area in the motor cortex is represented by the legs, feet and the hips. Coming down, it is the trunks, arms and the fingers. More down is the neck and the thumb, and lower down is the head and neck. So here if you see, basically above downwards when you come down, the topmost part of the motor cortex is being represented topographically by the legs. The middle part somewhere down is represented by the arms and the thumbs, and again in the other side you will find feet and the fingers. So basically the representation is a upside down representation of the body, where in the motor cortex the body is represented in an inverted pattern, where the above downwards normally it should be the head, neck, upper limb and the lower limbs. But in the motor cortex, the topmost part of the brain or the topmost part of the motor cortex have a representation of the legs, feet and the hips. Coming down it is the fingers, arms and the trunk. Coming more down it is the neck and the thumb. So this is an inverted representation, and see the area, the more the area of the motor cortex is represented by the fingers and other areas. Then when you come into the supplemental and the premotor areas, here it is the hand skill. As I said that fine tuning the movements, adding the movements. If you want to move your arms and the legs, the instruction will come from the motor cortex that particular flexor group of muscles have to contract. But adding to the tone of the muscle and fine tuning it will come from the supplemental and the premotor areas. So mostly the hand skill, the finger skill, the hand rotation, the eye movements are all being controlled by some specific areas in the supplemental area, supplemental motor area and the premotor area. The cortex, you see that in the upper lobe you will find that there is a control. This is the area 17, 18, 19 which is concerned with eye movements and eye fixation. Here you will find that the broca's which areas are there, the temporal association areas are there, where it is controlling the choice of words. What choice of words you need to make when you speak something comes from these association areas, and the word formation comes from here. It is the broca's speech area. See the functional organization here. See the functional organization. This is the representation. This is the motor cortex, primary motor cortex, and this diagram represents the area. See the topmost part of the brain, the upper part of the brain is representing the ankle, knee and the toes. As you come down you will find that lower down it is the hands and the fingers, and much more down is the representation of the face. By this diagram, the size of the diagram, you will understand that which area is being given more importance. See, the thumb is having so much of area of representation in the motor cortex. The fingers are having a big wide area of representation. Here you will find knee and the shoulders are having very less area being restricted. So the amount of the cortex which is representing the body also indicates the extent to which it controls the function. So the maximum representation in the cortex is for the fingers, thumbs and the palm. Here also you will find it is the eyelids and the eyeball, the lips, vocalization is being given the area. So the size of this represents the area to which it has been allotted or is being represented in the motor cortex, and secondly it is an upside down inversion. Normally the head should be above, the neck, the hand and the leg should be down, but you will find that the feet representation is up, below that is the hand and lower down is the face. Now some specialized areas of the motor cortex, briefly I will give you the functions. The Broca's area is concerned with speech. Any damage to the Broca's area will cause a decreased capability of the speech. Speech capability is reduced. That means what? See, when you speak, you have two things. One, the exact word formation is one thing, and the other, the choice of the words which you are going to use to convey your thoughts is another thing. So two aspects of functions are involved here in speech. One, the thought process which is happening in the brain, what you want to speak. The other is the word which is responsible, the word you are using to convey that thoughts. So both these functions are different. Broca's area is mostly concerned with word formation. Damage to that will cause the decreased ability to form words. Then eye fixation and head rotation area is there. It is for coordinated head and eye movements, especially when you see this head area and the eye movement, especially when you are playing a game, when you are playing a football, you need to move your head and the eye so that it tracks the ball. So that gives a coordination between the eyes and the heads, and that is controlled by the supplemental and the premotor area. The hand skill area is also the area where you use your fingers. Say for example, in writing, when you are writing, when you are making words and you are making sentences, the way you write, the is coming there, and when you are typing on the system, the word, the way the fingers are moving, or when you are playing a musical instrument, the movement of the fingers, all this comes under the hand skill area of the motor cortex. Now, how are the signals transmitted from the motor cortex down? Remember that there is a signal which is known as the descending pathway. So the signals from these areas of the brain has to reach the ultimate target or ultimate effector, that is the muscle. So how is this happening? So signals from the motor cortex or impulses from the motor cortex are transmitted to the peripheral, that is the muscles, by means of descending tracts. And these descending tracts are again called as motor tracts because they are functioning motor area. They are carrying impulses from the motor cortex. So when they carry the signals, they cause the muscle contraction to happen. So they are the descending tracts or the motor tracts. There are two pathways. One is a direct pathway and the other is the indirect pathway. So now what is direct pathway? The direct pathway is the corticospinal tract, where the signals or where these nerves or these tracts take its origin from the motor cortex. They pass through the various areas of the brain, that is the internal capsule, the midbrain, the pons, the medulla, that is the brainstem, and then they end on the spinal cord. At the level of the spinal cord, then they come out of the spinal cord through the motor region, that is the anterior horn cells, and then they supply the motor nerves to the muscles. So ultimately, the signal for moving comes moving. Let's say for example, you want to move your fingers. So the signal comes from the cortex. The signals are transmitted down through the descending tracts, that is the corticospinal tract, and ultimately it goes to the flexors of the fingers, and then your finger moves. So this is a direct pathway. It is for fine detailed movements. There are certain indirect pathways also which are coming from the cortical areas, but they are going to the different areas of the brain. As they descend downwards, they also receive signals from the basal ganglion, the cerebellum, and the brainstem nuclei. So these are known as the indirect descending pathways or indirect motor tracts. The corticospinal tract basically are made up of bed cell fibers. They are huge, large cells. 34,000 bed cells are there, and they are about 3% of the fibers. 97% of the fibers are small in diameter. Basically, they give around the background tonic signals, and they also give rise to the various feedback signals from the peripheral areas to the brain. Now, the other motor cortex, the other pathways from the motor cortex is first the bed cells, that is the motor cortex, will help in sharpening the boundaries of the excited signal. What does this mean? Sharpening the boundaries of the excited signals. Sharpening the boundaries of the excited signals means that suppose you have to move your index finger and middle finger only. The nerve fibers which are coming downwards comes from the motor cortex down to the spinal cord, and from the spinal cord to the motor nerves to the fingers. They are all bunched in a small narrow gap, and they are dividing and then going to the different fingers. Now, if you just want to move your middle finger, index finger or middle finger, but not the ring finger and the little finger, the signals have to has to be so discrete enough or sharp enough that they do not cause movement of these two fingers, but only the two fingers and the thumb are movement. So this causes sharpening of the signals, that is, the nerve fibers adjacent to it, the bed cells adjacent to the other area should not get stimulated. So basically the collaterals which are going back will sharpen the signals so that a discrete movement happens. So if you just want to move the index finger, you will see that only the index finger moves. The other fingers will not move along with it. Though the nerve supply is common, the muscles are going to all the four fingers. That is called the sharpening of the signal. Then there are certain fibers which are going from the bed cells or from the motor cortex to the cortical nucleus. They are also in the spinal tract, where they begin from the red nucleus and send axons to the spinal cord. Then you also have got that reticulospinal tract, vestibulospinal tract, pontospinal tract, from the pons to the cerebellum and also to the spinal cord. In addition to this, there are basal ganglion, brainstem and cerebellum also receive a large number of signals from the cortex. That means from the cortex, some fibers are going as it comes downwards and goes to the spinal cord. Some signals are going to the basal ganglion cortex, some are going to the brainstem and ending, some are going from the cortex to the cerebellum. Now, in addition to this, there are certain incoming sensory pathways to the motor cortex. They are the subcortical fibers from the adjacent areas. They pass through the corpus callosum from the opposite side also, and these are basically cutaneous and proprioceptive fibers. Then the thalamus, we know that the highest center for the sensory signals is the thalamus, especially the ventrolateral nuclei and the ventro-anterior nuclei of the thalamus is responsible for the coordination of the function between the three areas. We know that the primary motor cortex and the motor cortex is controlling the root signals, but the basal ganglion and the cerebellum are also fine-tuning it. So there is a coordination which should happen between the motor cortex, the basal ganglion and the cerebellum. The motor cortex will basically give a signal that the muscle has to move, the hand has to move. But the basal or the cerebellum will give us the signal or give information how much energy is required for the movement to occur. And the basal ganglion will coordinate between the two fingers in the group of the muscles. So basically there has to be coordination. The idea is that you have to lift a bucket of water. So signal to lift that bucket of water basically comes from the motor cortex to the fibers of the motor fibers to the muscles of the forearm and the arm, but that crude signal is coming from the motor cortex. Fine tuning how much energy and other things has to be applied has to come from the cerebellum and the basal ganglion. Then we also have got the rubrospinal tract. The rubrospinal tract is nothing from the red nucleus into the spinal tract. It is somewhere a part of the bed cells are also involved in this. The magnocellular portion gives rises to the rubrospinal tract. What does the stimulation of the rubrospinal tract gives? Stimulation of the red nucleus relatively causes fine motor movements, but these fine motor movements are not as good as the primary motor cortex, but it gives a background support for the fine motor movements to happen. So here this is the red nucleus, you will find that this is the cortico-rubral tract, where you will find that from the motor cortex to the red nucleus. So this is the cortico-rubral tract. From the red nucleus you will have certain signals which are going down into the spinal cord and it forms the rubrospinal tract. This is the reticular formation where it is passing through. Now what is the support of the body against gravity? The muscles of the spinal cord and the extensor muscles of the legs support the body against gravity. So basically when you are standing in position, your body weight is fighting against the gravity. The gravity is trying to pull your body downwards, but the spinal muscles are trying to see that you stand erect and against the gravity. So which muscles are taking part in again helping you support the body against the gravity? It is basically the spinal cord and the external muscles. Now these muscles are under the influence of the brainstem nuclei. Basically it is the pontine reticular formation, that is the reticulospinal tract, which is coming from the pons, is responsible in keeping these muscles contracted or the anti-gravity muscles contracted. So when these anti-gravity muscles are stimulated, they contract and they prevent the body from following downwards. Whereas the medullary reticular nuclei inhibit the anti-gravity muscles. Say for example, if you want to sit down, these muscles have to relax. So the anti-gravity muscles to relax and not to contract, this we have already discussed that there are about layer 5, the motor neurons are present in the layer 5, 50 to 100 giant pyramidal cells are needed for one muscle contraction to take place. Mostly they are in coordination with the corticospinal tract and the rubrospinal tract. Ultimately, they will innervate the muscles of the fingers and the hands. So now what is the control of the motor function by the body? So the motor function of the body is controlled by three basic organs, where it is the primary motor cortex or the motor cortex. You have the cerebellum and you have the red nucleus which is controlling it. Apart from it, you have got the reticular formation also controlling these functions. So basically, all the structures which are involved in the control of the motor functions is basically the motor cortex. You have got the cerebellum, you have got the basal ganglion, you have got the vestibular tract which is controlling, then you have got the reticular formation. Then the pontine reticular nuclei. This is what I had said earlier. The pontine reticular nuclei passes signals downward from the pons and to the spinal cord, and it is known as the pontine reticulospinal tract. This pontine reticulospinal tract is responsible for the contraction of the anti-gravity muscles, whereas the medullary reticular tract is the reticulospinal tract which is which is originating from the medullary region of the medulla, where the reticular formation is present, and they inhibit the anti-gravity muscles. Now what is the cerebellum responsible? The cerebellum is responsible for coordinating the muscle activity. It gives a sequence to the motor activities. Say for example, when you are playing and you are lifting a cricket ball, the sequence of events is the ball is approaching to you, you are moving towards the ball. When the ball reaches to you, you bend down, you lift the ball, and you then throw it back to the fielder. So all this requires the coordination. So this coordination, stepwise coordination, one event, one motor activity followed by the next motor activity, this sequencing is done by the cerebellum. And this also cerebellum along with the basal ganglion gives an idea of how much amount of energy is required, how much force of contraction the muscle should contract so that the ball reaches that particular area or reaches that particular fielder when you are throwing it back. So this coordination is done by basically the cerebellum and helpful by the basal ganglion. Now what are the motor functions of the basal ganglion? Basically it is a complex functions which are taking part by the cerebellum, by the basal ganglion. For example, the control of the complex pattern like writing, when you are using a cutting through scissors, when you are removing a dirt, and some part of vocalization involves the basal ganglion. So basically, where is the integration taking place? The integration of the motor cortex is taking place, one at the spinal cord, second at the brainstem, and third at the cortical level. What happens at the different levels? At the spinal cord level, it is the pre-programming of the pattern, that is the walking, running, etc. will take place at the spinal cord. The brainstem level helps in maintaining the equilibrium when you are moving this, when you are performing these movements. Cortical levels, at the cortical level, it will give into a pattern of the muscle contraction to take place. The cerebellum will do all the planning to happen. Basal ganglion will just help subconsciously to accomplish that movement. For any particular complex movement to happen, you have to learn that, so that this is pre-programmed. Once it is pre-programmed, then it will be the basal ganglion which takes part in activating already learned complex activities. Say for example, running. When you were a young small toddler, you never knew how to run, but as you grew older, you begin to walk and you begin to run. When you begin to run, there is a complex pattern of movement of the hands, movement of the body, that is the trunk, and the movement of limbs. So all these things where a complex activity is involved, and the sequential where one leg has to come forward, the other leg goes backward, then when the step is over, the next leg comes forward and takes back the other leg. All these things are done with the help of the basal ganglion, whereas the equilibrium and the planning is done in assistance with the cerebellum. So with this we finish the motor tract and the motor cortex. The other topic, a small topic which I would like to complete again here, is the hypothalamus. there was a request for the hypothalamus to be discussed. Basically, I will just go through the various functions of the hypothalamus here. It's a big topic. I will just go through the functions. Now we know that hypothalamus, the word hypothalamus says that it is below the thalamus. It is the oldest area of the brain. There is a hypothalamus hypophyseal connection between the pituitary, and that is known as a vascular connection. There is a neural connection also. This we have discussed in detail about the hypothalamo and the pituitary axis. I will just go into the functional areas of the brainstem. Basically, if you see the hypothalamus is composed of many group of nuclei. Now basically it is divided into anterior group, posterior group and a middle group. Each group has got a particular function, and each group of nuclei has been named after something. Say for example, the anterior group, because it is present in the front, is anterior, behind it is the posterior, and in the middle group of nuclei. So now this, in the anterior group there are again subgroups, and each of these group has got particular nucleus. Say for example, the paraventricular nucleus in the anterior group controls the oxytocin release and the ADH. The medial preoptic area is concerned with bladder contraction and controlling the blood pressure in the heart rate. Then you have got the posterior preoptic and the anterior hypothalamic area, which controls the body temperature, sweating and other areas. Then you have got the supraoptic nucleus. The supraoptic nucleus again controls the release of ADH. On the posterior side, you have got a many group of nuclei, where this group of nuclei have been named differently. For example, this is the dorsal medial nucleus. The dorsal medial nucleus controls the GI movements. Then you have got the posterior hypothalamus. The posterior hypothalamus controls again shivering and the blood pressure, whereas then this is the perifornical nucleus, which controls the hunger area and the anger. Then the ventromedial nucleus, which is concerned with the satiety or the sense of feeling of fullness after having some meat. In addition to this, there is a mammillary body which is controlled the feeding reflexes. You have got the arcuate nucleus and the lateral hypothalamus. This lateral hypothalamus area and the arcuate nuclei control the thirst and hunger. So basically, you remember, the hypothalamus is one area or the highest center which controls the autonomic functions. Thalamus is an area where all the sensory stimuli come and get relayed there. In the hypothalamus, almost all the parasympathetic or all the autonomic activity comes under the control of the hypothalamus. So there are a lot of afferent connections and efferent connections. This you will find it in the books, where you will find that there is a connection from the hypothalamus to the other areas of the body, and from the other areas of the body you will find that there is signals going to the hypothalamus. So basically, one thing which is there is, see the hypothalamus, it controls the release of ADH hormone. Then indirectly it controls thirst. Then the hypothalamus is also concerned with the behavior and the physical aspect of eating. So lateral hypothalamus is concerned with eating. That is the desire to have food. When will you start eating? That desire to eat food is controlled by the hypothalamus. In addition to this, the general level of activity, your alertness and your anger. The ventromedial nucleus is concerned with being quiet and calm, and it is also concerned with the sense of fullness. That is, after eating some food, if you feel that there is enough of food, that is called as satiety. That satiety comes from the ventromedial nucleus. Then periventricular nucleus is concerned with the sense of fear. At times there is a fear emotion taking place of you, taking control of you. That part of fear is under the control of periventricular nucleus. Then in general it controls the feeding and it controls the desire for feeding. In addition to this, it also helps in the control of ADH. So not only the hypothalamus by its action or control over the feeding and the satiety. It also controls the energy intake and the energy output, thus keeps a constant check on the weight gain and the amount of energy which a person needs to spend on a day-to-day basis. Then it also makes a controls the regulation of temperature. There is anterior hypothalamus, posterior hypothalamus. This anterior hypothalamus is controls the day temperature when the body becomes warm. The posterior hypothalamus controls in cold conditions. Then it is also responsible for the sleep wakefulness cycle. So the circadian rhythms which are in the body, where the circadian rhythms are in respect to your alertness, to your sleep, the variations in temperature, the variations in the day and the night, and the secretion of growth hormone, in the cortisol, all this is under the control of hypothalamus. The sleep wakefulness cycle, that is circadian rhythm of sleep wakefulness, also comes under the control of the hypothalamus there. Then the sexual functions, it is also responsible for the activation or for the onset of adolescence. Then autonomic functions, it controls both the sympathetic and parasympathetic functions. The posterior nuclei control the sympathetic effects, and the middle group of nuclei controls the parasympathetic activity. It controls indirectly through the osmoreceptors the thirst and the desire for the amount of water to be taken, water intake. Then it also controls stress. A highly functional area where the hypothalamus controls is the stress on the body. So whenever there is a stress on the body, through the signals from the cortex, limbic system and the reticular formation, the hypothalamus releases the neurons through the cortisol, and this cortisol controls the cortisol, and this cortisol controls the amount of food you intake, controls the amount of sleep you have, controls the blood pressure, the heart rate, and all other things are under the control of this hypothalamus. In other words, whenever there is a stress in the body, it is the hypothalamus which also takes part in the regulation of the stress. Then indirectly, it is the last